Hello guys, welcome back to my YouTube channel. Today we are going to understand new topic that is different types of addressing. Let's start. Criticize 3 address instruction and 0 address instruction with common example. 3 address instruction. Computers with 3 address instruction formats can use each address field to specify either a processor register or a memory operand. For example, let's take one example, that is x equals to a plus b into c plus d. So for that, first we need to do addition in register R1. After that we will add c plus d in R2, and after that we will multiply R1 and R2 registers. The advantage of 3 address instruction is that it results in short programs when evaluate arithmetic expression. Disadvantage is that binary coded instruction require too many bits to specify 3 address instruction. For example, commercial computers. Now 0 address instruction. A stack organized computer does not use an address field for the instruction add and multiply. The push and pop instruction, however, need to address to specify the operand that communicates with the stack. So the example is x equals to a plus b into c plus d. Same example we need to take. So take a same example. In that we need to first push the value a onto the stack. After that push the value b to the stack. After that we will do addition between a plus, and now we will do now we will add to stack C and D. After that we will perform addition on C and D. After that we will multiply C plus D and A plus B and store the result in the X. To evaluate arithmetic operation result, reverse Polish notation is required. That was we have studied in SAM 3, that reverse Polish notation. After that, now we will understand 2 address instruction. Two address field can specify either a processor register or memory word. For example, same example. Now we will need to do is that store the memory address in the R1 register. After that we need to now, so it's also stored in memory, so we will directly do what, store the value in register R1, same registers, and use the previous value which is stored in R1 plus memory address of D. After that we will store the result in R1, and we will take new register for for memory address of C, and in a same register we will store the result of memory address of C and D. After that we will do is R1 into R2 and store the result in the memory address of X. So in this we does not every time take new register to store the answer or to store the memory address. But we reuse the previous register only. To move operation, moves or transfers the operands to and from memory. As now the video will be long, so we will stop it here, and in next lecture we will discuss about 1 address instructions. So guys, thank you for watching, and if you have any suggestion then please do comment. We